Okay, so let's just start with core Java. So how much do you rate yourself in core Java out of 10?
Yeah, I will say maybe 6 or 6 to 7. Yeah.
Okay, okay. Okay, can you tell me what are the uh, core Java things you are aware of or you are good at or you have worked on? Yeah, so tell me in very brief.
Yeah, I have worked on OOPS principles, and then um, I have also worked on collections framework and multi-threading. Also, I have worked on, and then exception handling, Java 8. So yeah, so these are the things I have mostly worked on.
Okay, so what is OOPS concept in Java?
So OOPS concept is something that uses the concept of objects to model the real world entities and their interactions. So Java as an object oriented language employs OOPS principle to create modular, reusable and maintainable code. The core principles of OOPS in Java are encapsulation, inheritance, polymorphism and abstraction. So encapsulation basically refers to the like bundling of data and methods that operate on the data into a single unit called an object. So in Java, this is achieved using classes. So encapsulation also involves restricting direct access to some of the object's components, right? So basically we use private, protected and public these access modifiers in order to do this. So this mechanism basically helps in hiding the internal state of the object and only exposing the necessary part, ensuring the clear separation between the object internal state and external behavior. So uh, we write normally getters and setters method for this. So whenever we have a bean class, so in that we write getters and setters method, and using so we keep the like all the variables as like private, and the getters and setters normally we keep as public, and because of public we can access the data. Then coming to inheritance. So inheritance is a mechanism that allows one class to inherit the fields and methods of another class, right? So basically the superclass or base class you can say. So this promotes code reuse and establishes a natural hierarchy between classes. So in Java, inheritance is implemented using the extends keyword. Inheritance enables polymorphic behavior and facilitates the creation of a, more modular and hierarchical class structure. Um, then polymorphism. So in polymorphism, we have two types of polymorphism. One is compile time, and the another is run time. So compile time basically is method overloading, and run time is method overriding. So in compile time polymorphism, so that occurs when multiple methods in the same class have the same name but different parameters. The method to be invoked is determined at the compile time in this case. Okay, and then coming to runtime or method overriding. So that occurs when a subclass provides a specific implementation of a method that is already defined in its superclass. So this method to be invoked is determined at runtime based on the object's actual type. So now the last one is the abstraction. So abstraction is the concept of hiding the complex implementation details of an object and exposing only the essential features. It reduces complexity by allowing the user to interact with the object through a simplified interface. So in Java, abstraction can be achieved using abstract classes and interfaces. So interface, we say like 100% abstraction, and abstract classes, so we can achieve the partial abstraction. So an interface is a reference type that contain abstract methods and constants, and it defines a contract that implementing classes must fulfill. Okay, and then abstract class is a class that cannot be instantiated and may contain abstract methods. So basically it will have a method without implementations. So we say those methods as abstract methods. So yeah, so these are the basically all OOPS concepts which I am aware of. Yeah.
Okay, can you tell me what are the different methods in the object class?
Yeah. So we have toString is there, then hash code is there, notify all, um, then equals is there. So and clone is there. So yeah, these are the methods we have.
Okay, okay, so what is equals method used for?
Yeah, the equals method in Java is used to compare two objects for equality. It determines whether two objects are considered equal by comparing their contents rather than their references in the memory. So the equals method is defined in the object class, and its default implementation compares the memory addresses of the objects. So that means two objects are only considered equal if they are the exact same instance, and the memory location is same. So that's what is the equals method in the object class.
Okay, so as you said, two objects are only considered equal if they are the exact same instance, right? So if suppose if we have the some ABC string, and again we say ABC dot equals again ABC string in double quotes, right? So how it is going to behave?
So ABC, okay. So the ABC, so the ABC equals double quotes ABC. So ABC is also a string, right? The first ABC.
Yeah,
So when we call ABC equals I mean in double quotes ABC. So if the ABC is a string, then in an instance of uh, then the like equals method will compare the content of the string. So it won't compare the memory addresses. Okay, because the string class in Java overrides the equals method to compare the actual sequence of characters.
okay. So what is the difference between double equal to and equals?
Yeah, so the double equal to operator compares the memory addresses of two objects. It checks whether the two reference points to the exact same instances in memory. So for primitive data types, double equal to compares their actual values. However, for objects, it verifies if both reference points to the same object instances. It's worth nothing that double equal to cannot be overridden and primarily checks for reference equality. On the other hand, the equals method compares the content or state of two objects for logical equality. By default, equals in the object class behaves similarly to double equal to comparing memory addresses. However, many classes in Java like string, integer, so they all override equals to compare the actual data content within the objects. So in custom classes, equals should be overridden to provide meaningful comparison based on the object attributes. So this method allows for logical equivalence rather than just a reference equality. So in short, like while double equal to used for checking reference equality, equals is employed to determine logical equivalence by comparing objects content. Okay, understanding this distinction is, required for correctly implementing object comparisons in Java applications. So yeah,
Okay, so what is equals and has code contract?
yeah. In Java, the equals and has code contract is a set of rules that must be followed when overriding the methods in classes. So like these methods are crucial for object comparison and hashing. So especially in collections like hash set and hash map. The contract includes two main rules, consistency and equality. So that implies the same hash code. So consistency mandates that if two objects are considered equal by the equals method, they must produce the same hash code when the hash code method is invoked. Similarly, if equals returns true for two objects, their hash code must also be equal. Okay, so adhering to these rules ensure the proper functioning of the objects in collections, preventing unexpected behavior such as object not being retrieved correctly or something. Okay, so to implement the contract effectively, so we should must ensure that equals reflects the equality logic of objects consistently, and hash code generates hash code based on the same attributes used in equals. So by upholding the equals and hash code contract, developers can maintain the reliability and integrity of their Java code, particularly when working with collections that are that mostly rely on correct hashing and equality comparisons.
So suppose I have an employee class, and in this class we have, let's say, ID, name, and salary. So now, um, suppose if I want to sort based on the name, and sometimes I want to sort based on the salary. So I have some bunch of employees, and so you have to keep this in some collection, and then you I want to sort it sometimes based on the um, name and sometime based on the salary. So what approach you will follow for this?
Okay, to sort the list of employees based on the different properties or criteria such as name or salary. So suppose our requirement is to sort based on more than one property in a class. So we can use comparator for this scenario. So we have a comparator interface, and in that along with that we can use collections.sort method or the stream.sorted method. So uh, so that is how we can achieve it. So and yeah, and comparable we can use when we have only one property to be sorted. So we can use comparable in that case. So yeah.
Okay. So in Java, why string is immutable?
So immutably ensures that once a string object is created, its value cannot be changed. So this property makes a string thread safe, meaning they can be safely shared among the multiple threads without the risk of concurrent modification issue. Okay. And secondly, immutability enables a string interning. Uh, so this is basically a process where duplicate string literals in the code are replaced with reference to the same string instance in memory. So this optimization reduces memory consumption and improves performance by reducing the number of duplicate string objects. And additionally, immutably simplifies memory management and allows for certain optimization such as caching hash codes, which can improve the performance of hash based data structures such as hash map. So yeah, so basically immutability in Java, uh, basically it contributes to the safety, stability and performance, and which makes it easier to reason about string manipulation operations in Java programs.
Okay, so suppose we have string s equal to Akash, and in the next line we have s equal to Pathak. Okay, so and then we say system.out.println s. So what will be the output?
Yeah, so it will be Pathak only. So because we have string s equal to Akash and then we replaced s with the next string. So Pathak, so the Pathak will be the output.
Okay, and what will happen to Akash, that string?
So yeah, so basically this is the concept of I mean string constant pool. So as soon as we create a string s equal to some string, let's say Akash in our case. So in the string constant pool, that s will be referencing to the Akash, and then as soon as uh, we do the next line, we say s equal to Pathak. So in that case, the reference which was there earlier, it start connecting with the Pathak. So Akash will be there in the memory, and S will be reference to the, so the Pathak will be reference to the S, and later on that Akash string what we have, that will be garbage collected. So yeah.
So what is a static keyword in Java?
Yeah, in Java, static keyword is used to declare a member uh, that belongs to class itself rather than to instance of the class. So so it can be used either with like static. We have a static fields, we have a static methods, we have a static blocks. In case of static fields, so it will be like something like suppose a static, we have a class, suppose class ABC, and then we can put a static int count equal to 0. So so the count field will be declared as a static, and it will be shared among all instances of like ABC class, and its value will be incremented each time a new instance of ABC class is created. And similarly, we have a static method. So we have, for example, if suppose if we say math util, public class math util, then suppose we have a method public static int add, and it suppose it accepts two variables int a and int b, and we're returning a plus b. So in this example, the add method is declared as a static, so it can be called directly on the class without the need to create the instance of the math util class. Okay, so we don't have to create the instance of it. So directly we can say math util dot add, and we can just pass the variables like whatever 3 comma 2 or something, whatever we want. So we don't have to say new keyword and create the instance of it. Then it is also used as initialization block. So suppose any class is there, and in that, in the static, and then curly braces start and end, and whatever we mention under that, so that we say like it is initialization block. So it can be used to perform one-time initialization task, such as loading of some configuration settings. So yeah, so these are the various usage of a static keyword.
Okay, can you tell me the difference between linked list and array list?
Yeah, so there are various differences between linked list and array list. So array list basically uses dynamic array internally, and linked list uses doubly linked list internally. Okay, and then uh, so in in the case of array list, so insertion and deletion are slower, and in case of linked list, insertion and deletion are faster. Okay, and suppose the scenario is like um, so basically array list is suitable for scenarios with frequent random access, and in linked list is suitable for scenario with frequent insertion and deletion at any arbitrary position. So yeah, so these are the, I mean, various differences between them. Yeah.
Okay, can you explain what is the load factor?
Yeah, so the load factor is uh, parameter used in hash-based data structures such as hash map and hash set. So to determine when to resize the internal array or table that stores the elements, so then we use this. So in Java, hash map and hash set, the default load factor is 0.75. So this means that when the number of elements in the collection exceeds 75% of the capacity, the the collection will be resized to increase its capacity and maintain efficient performance. Increasing the load factor allows the data structure to hold more elements before resizing, which can reduce the frequency of resizing operations and improve memory efficiency. However, a higher load factor may also increase the likelihood of collision. So, where multiple elements map to the same hash bucket, so potentially degrading performance due to longer lookup times. So overall, the choice of load factor depends on the specific requirement of the application. So balancing factors such as memory usage, performance, and expected number of elements in the collection. So adjusting the load factor can help optimize the performance and memory efficiency of hash-based data structures for different use cases.
Okay, so what is exception handling in Java?
So exception handling in Java is a mechanism used to deal with like runtime errors, also known as exceptions, in a systematic and controlled manner. So exceptions are unexpected events that occurs during the execution of a program, such as, for example, if divide by zero. So accessing an invalid index in an array or attempting to open a file that does not exist. So these all comes under the exception. So in Java, exception handling is accomplished using the combination of try, catch, and finally and throw keywords. So
Do you know what is throwable?
yeah, in Java, throwable is the superclass of all errors and exceptions. So it is the part of java.lang package and serves as root of the exception hierarchy. The throwable class has two primary subclasses, error and exception. So error represents any serious issues that a reasonable application should not uh, uh, try to catch. So error are typically abnormal conditions that indicates a problem with the Java virtual machine. So other or any other serious conditions. So for example, it can be out of memory, it can be stack overflow, or maybe virtual machine error. So these all comes under error. Then we have exceptions. So exception represents conditions that a like application might want to catch. So that are conditions that can be anticipated and recovered from. So while we write the program, so then and there itself the we can write the code to handle the exception. Okay, so again this exception has two different kinds of exception. We have checked exception and we have unchecked exception. So exception that is checked at compile time, so they must be either caught or declared in the method signature using throws. Okay, so for example, IU exception, SQL exception. So these all comes under the checked exception. Then we have unchecked exception, so that happens at the runtime. Okay, so exceptions that are not checked at compile time, so they usually a result of uh, programming errors. So examples, for example, null pointer exception, array index out of bound exception, or maybe illegal argument exception. So yeah, so these are the various examples of unchecked exception. Yeah.